I posted a video a couple days ago about using the Pico PIO Micropython to do the a distance sensor in PIO and controlling the distance sensor in the PIO. So that was uh, I did the video, I did the code and finished it up kind of late at night and did the video. And I slept on it and woke up the next morning. This is the original code. And I said, man, there's a lot of jumping around in here. And I couldn't even, it was hard for me to follow. Um, so I decided to clean it up a little bit and only save one line of code really, but it's more easier to follow the code through the basic thing. So we're basically this is setting up our 300 so that we can count down to from 300 to 0 so that we time out after 300 centimeters or 3 meters. Um, that's what those lines of code do. And then we set up the trigger to go high and for 10 microseconds and then go low again. And then we're waiting for the echo pin to uh, go high to start our timing loop to see how long the takes for the uh, echo to get back. And so we're doing that, and then we're that's a timing loop. And so we first thing we need to do is decrement so we can do our timing. We're using this 28 and 28 to create the mill uh, 58 because you got 28 plus 1, 28 plus 1. So you got uh 20 29 times 2 is 58 microseconds, and that's how long it takes to get a centimeter. I explained all that in my last one. But we're decrementing here, and as long as we're not at 0, we're just going to jump down here to echo, and then we're going to check to see if the um, pin has gone low. And uh, if it hasn't, then we're going to jump back up here and just loop through here. This is our loop that we're doing. And we're just going to keep doing that. So you have two ways of exiting this loop here. If um, the X decrement gets down to 0, meaning that you timed out, then you'll go to the delay and go ahead and you know do your timing down here so that you don't do too many readings per second. I think I'm striving for about 100 milliseconds per reading, and so that's what that does, and it times out and then goes back to the top. The other way it can jump out of here is if the jump on the pin, if the pin goes low, then we're going to send whatever the X value is out through the ISR and then push it out to the uh, uh, FIFO register. And then I also have this, mentioned a lot of this in the other video, but I got the IRQ, which automates the get for that. So I have a, uh get CM as the IRQ thing that we have, and all we're doing there is because we counting down, so our get is going to be less than 300, and then but to get our distance, we have to take 300 minus that because we're counting down. So that'll give you your distance, and that gets run every time that we send something, push something to the FIFO register. So we're pulling it out as soon as we get it. So that was one of the uh, revelations for me that you can automate your get pretty easily using the ISR. And then, like I said, then like you say, you have the timing there. But I was looking at more documentation on the PIO. And I really this set here where you got to push in, you can only push in 5 bits at a time to the ISR. Um, it's and you have to use the ISR if you're doing this in thing here. So um, we you're doing this and each time, so we have nine, we want 300, so it's a 9-bit binary number. So you have to do it twice. You have to send in the 5 and then send in the 4. And I often wonder, well, if you had a lot longer number, so if you wanted to put, you know, uh, anything over 1,000, I think you have to go ahead and uh, use another one, and you need to set it and then in again. And so if you had a big number you wanted to hear, you use up a lot of your instructions doing that. And I kind of found a way that we can do it using the exec execute, I guess, thing where we can automate putting a number into our OSR before we do it, a full number. This one, I also, to get to 300, I had to figure out what the binary was, and then we shifting the parts of the binary in. But using it as where we do an automated put before we start our code, activate our code, we're able to get rid of those four lines of code. So that's kind of cool with these 4 lines. And then, of course, if we're pushing it or putting it and then pulling it into, we're going to be pulling it into the OSR. So OSR is going to end up being our register that we're going to use for long-term storage of that 300. That's why we only have to do it once, because OSR, as long as we're using move, the OSR is not going to change. It's just copying, and we call it move, but it's really copy. So OSR is going to maintain that 300. So let's get to that code. So like I said, um, basically we took out the first 4 lines, and the first line now is move OSR to X. So uh, OSR has to be, I didn't even change my thing here on that. So let's do that right now. OSR. And we can say that that is saved because, like I said, once we put it in there, or pre-filled, how about pre-filled? So OSR is going to be pre-filled, so that's good. And then, like I said, we're using, we're setting up, everything's the same down here. We're setting up our IRQ so that our output is automated. But then we're going to do this, we're going to, before we even activate it, we're going to put this 300. That's another good thing. I didn't have to do any of the binary thing. I can put this in as a whatever number I wanted. If I wanted 1,002 or something like that, I wouldn't have to figure out what the binary is. So I'm just putting a decimal number in there. And then you do this exec execute, and you can do a any of your things in there. You could actually run a 1-line code if you want to put a bunch of these in there and you just wanted to run them once. You could do that, I think. And uh, but this, I'm pretty sure this all has to happen while it's not active, because you wouldn't want to, because you wouldn't know where any of this was going to go in there when it happens. So uh, all that happens before we make it active. So we are saving lines in here, but we're adding a couple lines here. But we got as many lines in MicroPython as we want, but we only got the uh, limited number of lines in our PIO thing. So, like I said, it eliminated 4 lines of code in the PIO, and like I said, it makes it easier because we can just, whatever decimal number we want, we can push it in there. You have a limited number, like you say, you got the X and the Y, and you got the ISR and the OSR, and that's the only 4 registers you got to work with in your PIO. And So uh, the other code wasn't using the OSR at all. And so now we're being able to use the OSR for long-term storage of that number that we have. And as long as the program runs, it's going to stay in there. So this only has to happen once, and then it'll be an OSR and we're good to go. And as you can see down the bottom, I actually have it running now and moving back and forth. And I pointed at the seal, and it should be 160 something, 166, 167. There you go. So, anyhow, I'm gonna post all three of these and link to them in the description. But learning a little bit more about the PIO every time I reread the documentation. Thanks for watching. Have a great day, everybody.